In this section, we're going to look at how to represent complex numbers graphically. And at first, it might seem a bit weird to try and represent a number graphically, but you've been doing this since you were in primary school. A real number can be represented graphically using a number line. Here we've got a number line, and if I wanted to place the real number 1.5, I would know that I would put that there on the number line in between 1 and 2. And because of this, these real numbers are called one-dimensional. You can think about them as being one-dimensional because you can place them on this one-dimensional number line. Complex numbers are really useful because they are two-dimensional. Because a complex number, say z is 2 plus 5i, because it's got these two parts, the real part plus the imaginary part I, you can kind of think about this as a two-dimensional number. So the way that we're going to represent these complex numbers isn't just using a number line. We're going to have to use two number lines, or basically we're going to create a coordinate grid. So along the horizontal axis, we're going to put the real part of the complex number, or we could just say RE instead of writing real. And here we're going to put the imaginary part of the complex number. So if I wanted to plot this complex number, I'm basically going to plot the coordinate 2, 5. So the real part needs to be 2, and the imaginary part needs to be 5. So at that coordinate 2, 5 is this complex number z, which is 2 plus 5i. If I wanted to plot another complex number, say the complex number alpha, which is minus 2 minus 7i, then all I would do is plot the coordinate minus 2 minus 7. So I want the real part to be minus 2 and the imaginary part to be minus 7. So I could plot that complex number alpha over there at that coordinate minus 2 minus 7i. Okay. So let's have a look at example 1 then. Let's draw a grid. We're going to put on the horizontal axis the real part and the vertical axis the imaginary part, and we always label it that way around. Now you'll see this word here, it says Agrand diagram. This diagram that we've just drawn with the real axis and the imaginary axis is called the Agrand diagram. Another common word for describing the Agrand diagram, the real and imaginary axes, is the complex plane. Okay. A plane describes a two-dimensional object, and this is two-dimensional because you can go left and right and up and down. It's got horizontal and vertical dimensions. So let's plot these complex numbers on the diagram. So in an exam, when you need to plot a complex number, you just need to show the coordinates clearly. So we want to plot minus 4 plus I. So this complex number has real part minus 4. So we're going to go to minus 4 on the real axis, and we're going to go up by 1 to 1 on the imaginary axis. So we can plot that complex number, which is z1 at that coordinate there. The next complex number, z2, has real part 2 and imaginary part 3. So we're going to go to real part 2, and we're going to go up to 3 on the imaginary axis, and that's our complex number z2, 2 plus 3i. And then finally for z3, the real part of z3 is 2 and the imaginary part is minus 3. So we know that we're going to go along to 2 on the real axis and then down to minus 3 on the imaginary axis. So we'll just label that on our axis there. So that's our complex number z3. And actually you'll notice that z2 and z3 are complex conjugates of each other. That complex number and that complex number are conjugates. And that's because the imaginary part is plus 3 for this number but minus 3 for this number. So the sign has been changed, but the real part has stayed the same. So you can see that we've just reflected this complex number z2 in the real axis to make the imaginary part minus 3.